Okay, are we ready for our second algebra lecture? I think this one's going to be shorter and even easier than the last one, but we will find out. So, this is on section 6 and section 7 of chapter 1. Section 1.6 is Introduction to Equations. So, the first equation we're going to work with is x plus 5 is equal to 17. This is called an equation. So let's solve our first algebra equation, which maybe this isn't your first one. Who knows? Maybe it is. I have yet to find out. So we have x plus 5 equals 17, and we want to figure out what x is. What is x? That's the question. We've got to solve for it. So in order for us to solve for x, we need to get x by itself. What is in the way of getting x by itself on one side of the equation? And that is this plus 5. How can we get rid of it? Well, we have to do the opposite operation. So here we are adding 5 to x. So to get rid of it, we need to subtract 5 on the left side of the equation. Whatever you do to one side of the equation, you must do to the other side. To the right side, we will subtract 5. So what happens is these will cancel each other out, and we will get x by itself equals 17 minus 5 is 12. And I could box my answer. This equation wants to know what number plus 5 equals 17. 12 plus 5 equals 17. So maybe you could have figured out that 12 is the answer just by looking at it. But of course, the equations get more difficult. So in the other sections, we talked about expressions. And I just want you to know that an expression is different from an equation because an expression does not have an equal sign, whereas an equation does. We'll do a couple more examples. So the author presents the questions in exactly this way in section 1.6, and so I'm going to do the same. However, I would say this is an atypical way of asking someone to solve an equation. So it says, for the expression 1/3 x, find x if the expression equals 13. So what it wants you to do is to solve the equation 1/3 x equals 13. 1/3 of some number equals 13. 1/3 of some number is the same as 1/3 times the number. There are different ways to get x by itself. One would be to divide both sides by 1/3. And then you're dealing with a division with fractions, which really isn't that bad. My favorite thing to do, however, is to multiply by the reciprocal, which in this case would be 3 over 1. I like to do that this way. And whatever you do to one side of the equation, you must do to the other. And so these 3's cancel each other, and of course the 1's cancel each other. And we're left with x by itself. And then we have to do 13 times 3 divided by 1, which is the same as doing 13 times 3. 13 times 3 is 39. X equals 39. If you were to plug 39 back in, you would be doing 1/3 of 39 is 13. Hopefully you're on board with that fraction math, but if not, you need to definitely ask further questions. Moving on to example 3. For the expression 7x, find x when the expression equals 42. So when does 7x equal 42? So we have 7 times x. If we have 7 times x, the way to get the 7 out of the way would be to divide by 7. So these 7's cancel. 7 divided by 7 is just 1. And if we have 1 times x, that's the same as having x. Because 1 times any number is itself. 42 divided by 7 is 6. So x equals 6. All right. Solving equations. Here we go. So in the last section, we solved the equation x plus 5 equals 17. We got that x equals 12 by subtracting 5 from both sides. We call, if we take the 12 and we plug it back in for x, we get the equation 12 plus 5 equals 17, and we call that a true statement. So you're actually going to want to check your work when you solve equations a lot, and you're going to hopefully get a true statement. So if you get a false statement like 11 plus 5 equals 17, that's a false statement, and you should do the problem again. 12 is called the solution of the equation, or a solution of the equation. In this case, it's the only solution, but some fancy algebraic equations have more than one solution. So, taking a step such as subtracting 5 from each side is called transforming the equation. This is something that the author uses in his vocabulary, in his book. I haven't seen that any other place. Transform an equation until you get x equals some number. So those are vocab words he uses. And you can pause if you're taking notes and you haven't gotten this all down yet. All right, let's work 2 examples of solving equations. All right, example 1, 1/2 x equals 12. This is like the other example we just worked. I like to multiply both sides by 2. I'm going to skip the part where I multiplied by 2 over 1, the full reciprocal, because I know that the ones won't affect the final answer. And I get x equals 24. So if you start to get more familiar with these equations, you can start to skip some steps as well. Example 2, x minus 10 equals 12. So since the 10 is attached by subtraction, to transform this equation, as the author would say, we're going to have to add 10 to both sides. Whatever you do to one side of the equation, you must do to the other. So the negative 10 and positive 10 will cancel out. 12 plus 10 is 22. Okay, now if I'm a really good Algebra I student, I'm going to plug my answer back in and check my work. I want to make sure that 22 minus 10 is in fact equal to 12. It is, that's true. Now I'm feeling comfortable that I can box my answer. Ideally, you would do that with every problem. However, I think that you're going to be more tempted to check your answer with the more difficult problems. All right, the end.